係，好晚安啦各位，嘿嘿。有咩？今日就想快快脆脆就係唔好拖啊啲嘢，快啲睇完佢，然之後就可以去繼續打機。I mean 我自己打，我唔想 on stream 打，因為我依家咪之前買咗 PC 版 FF7 嘅，咁我想爆翻個正傳，或者應該係拆埋啲成就佢啊，完成埋啲成就佢 ，which is 咧就唔係真係咁有趣嘅。對於 stream 嚟講，我亦都其實開 stream 打機唔係一件咁有趣、咁開心嘅事情，好煩啊！就 enjoy 唔得打機嘅樂趣。咁如果有人陪你去傾下隻 game 嘅話還好，或者陪你傾下偈都好。最弊又冇人陪你傾，然之後你又要即係叫做開隻 stream 咁樣去打機，咁樣成件事唔係真係咁有趣對我嚟講，所以就算數啦。今日就快快脆脆做完正事就收工。好，係啦。上次又睇到睇先，我望一個 cam 一清唔清 ？OK， 冇問題，是但。上次我哋睇到較大聲啲先。其實我都唔係太 catch up 到佢發生咩事情，有啲位應該前少少咗。等下先。哇！要再前啲，再前啲。呢度最主要唔係太知佢突然之間多咗個 automorphism 嘅 symbol 喺度，究竟係 for 乜？for 咩咧？究竟要？我大概明嘅就係佢將呢堆 elliptic curve 分咗做唔同嘅 equivalent class 啦。如果我冇理解錯，佢分嘅方法就係同一如果係 isomorphic to each other 嘅，佢就分類做同一組。我唔知係咪，我唔肯定係咪，睇下佢係咪先。咁就係啱啱佢講咗啦，個 equivalent relation 就有兩款，一款就係 isomorphism， 一款係 isogeny。isogeny classes is determined by the number of points。咩 point 啊？A normal nitrace 係 equivalence to isogeny class。What the heck？ 聽唔明。一個 isogeny class 可以有好多個 isomorphism class。等先，咁所以如果我冇 get 錯，佢呢度所講嘅 isogeny 嘅意思係，只要佢哋嘅點數係一樣嘅話，就係分做同一個 class， 係咪？我冇 get 錯，睇下先。如果實際查 isogeny 先。 In mathematics in particular, an isogeny is a morphism of algebraic group that is surjective and has a finite kernel. What the heck? Surjective and has a finite kernel. 咁有關呢個 finite morphism 咩意思？有 subtitle， 自動產生嘅啫喎。睇下先，自動產生就冇意思啦。同埋我又唔係聽唔明佢講咩啊！我唔明嘅唔明佢英文講咩。有啲嘢就算翻譯咗或者有 subtitle 都冇意思。睇下先，我見到人睇下先，等陣啦。人問咗呢個問題。What is an isogeny of elliptic curve？ 咁我諗應該係 exactly 我想知嘅嘢。好多字啊 ！Should isogeny between elliptic curve are the basis for the quantum 咩 quantum resistant encryption method。But we didn't say what an isogeny is. What the heck？ 突然之間有關 quantum 咩事？突然間諗到去量子力學，係咪黐咗線？睇下先。In Wiki, you will read an isogeny is a morphism of algebraic group that is surjective and has finite kernel. 係啊。That's possibly misleading term here is algebraic group. It may sounds like they are throwing in the term algebraic for clarification as if to say a group be like the kind of you would talk about in math. 唔好意思，可能太細你睇唔到，大隻啲先。Wiki 話一個 isogeny 咧係一個 morphism of algebraic group that is surjective and has finite kernel。咁同我啱啱從阿 Bandcamp 度講嘢有啲唔同。佢啱啱話咩啊？話咩話？isogeny classes 係 determined by the number of points。我就唔知佢乜嘢 number of points 啊？咦？定係就係有幾多個 kernel 咁樣啊？佢既然係有 finite， 就係 isogeny 同 number of points 有關嘅嘢，就喺呢度所講嘅就應該係就 I mean。就係你 number of points 你梗係要 finite 先數到噶啦，咁所以呢一個 definition 入面唯一一個可以數到嘅嘢就係個 finite kernel， 係咪就係 determined by 個 number of kernel 咧？唔 sure 啊，唔緊要，繼續睇先。但佢呢度又繼續纏繞喺呢個 algebraic group 度。An algebraic group is indeed a group, but one with additional structure。就係 algebraic group 純粹就係一個 group。咁呢個一個 group 就梗係要有一個 operation 啦，而呢度嘅 operation 係 addition。A morphism is a structure preserving map, okay? And so here morphism means a function that preserves the algebraic and topological structure of an algebraic group。 呢個解釋咩叫 morphism。morphism 就係一個 map， 就係由 set A map 去 set B 咁樣啦嘅一個 map 啦。咁 where 咧一個 morphism 咧，佢由 set A map 去 set B 嘅時候咧，佢可以 preserve the algebraic and topological structure， 就係呢一個 mapping 係可以保存到，即係 set A map 咗去 set B 之後，佢會保存到個某啲特性嘅，可能真係叫做呢個 topologically 嘅一個特性啦，還是係 algebraically 嘅特性。呢樣都唔係重點，我想知究竟 algebraic group of elliptic curve 係咩意思啫？ The algebraic 唔係 isogeny of a elliptic curve 啊，唔好意思講錯。In the algebraic group, we care about our elliptic curve. OK, elliptic curve 係一個 algebraic group 嚟嘅。So let's specialize to elliptic curve. For the rest of this post, all definition and theorem has come from Handbook of Elliptic and Hyperelliptic Curve Cryptography。見到 cryptography 已經冇乜興趣。cryptography 係解碼學啊嘛，我記錯。講密碼學太實用啦呢啲嘢，太實用嘅我哋係唔會做嘅。OK This book defines isogeny implicitly by defining what it means for two curves to be isogenous。OK 咁兩個 curve 點樣先叫 isogenous 咧 ？Two curve 有兩個 curve 啦，呢個 E/K 同 E-/K。咁我簡稱佢做 E 同 E。總之有兩個 curve 啦，一個 E 一個 E-。If there exists a morphism， 但呢個 morphism 冇講係咩 morphism。homomorphism 就係一個咩話？homomorphism 係一個 function， 佢呢個 function 可以 perceive 到就係homomorphism。perceive 到呢樣嘢啦。呢一個 perceive 黐線，講咩英文啊 ？preserve homomorphism 可以 preserve 到呢一樣嘢。咁一個 morphism 又係點樣呢？A category C consists of two classes, one of object and other of what? OK， 呢度好似清晰少少。A morphism is a map between two objects。純粹係一個 map 咁樣。A general morphism is called homomorphism。總之有一個 map 啦，係。With 總之如果兩個 curve。咁存在一個 map 由 E 去 E' 啦 ，with coefficient in K mapping the neutral element of E to the neutral element of E'。咩意思 ？The neutral element is the identity element of the curve as a group. The points of infinity。所謂 identity element 就即係譬如話加數入面啊，喺加數入面嘅 identity element 就係0啦，即係 which is 一個 group 入面佢一個 element 同佢自己嘅 inverse 去有 operation 之後，佢會出咗啲咩出嚟咧？譬如一嘅 inverse 喺加數入面就係-1啦，咁1同-1做一個加數嘅 operation 出嚟嗰個 element 就係所謂嘅 identity element，which is 就係0啦喺加數入面。咁喺呢個 elliptic curve 嘅 group 入面咧，佢嘅 identity element 咧，上次有睇過嘅就係呢個 points of infinity 啦。咁 where 咧relate 到啱啱上面即係呢個 isogeny 呢個 definition 邊度啊？呢度有少少 relate 到落去呢個 definition 度啦 ，which is 有樣嘢係如果group A 去 group B，group A map 去 group B。咁 which is let's say 就係 group B 嘅 identity element 係0啦 ，let's say，OK，group B 有個 identity element 叫0。如果 group A map 去 group B， 譬如話有 group A 入面有 A、B、C 3個 element 咧，係會 map 落去 group B 嘅0呢個 element 度嘅。嗱 A、B、C map 去0，咁呢3個 element 即係A、B、C 呢3個 element， 我叫佢做 kernel 啊嘛，就係簡單嚟講，呢個 map 入邊有邊啲 element 係會 map 去另外一個 map 嘅 identity element 度，就係叫 kernel 啦。如果冇記錯嘅話，睇下先。Linear algebra 唔係 kernel group 嚟嘅 ，A、B、C 呢3個 element 係 form 到一個 set 出嚟，而呢個 set 就會叫做 kernel。It's a linear subspace of the domain of the map, which is mapped to the zero vector， 就係 map 去個 identity element 度。neutral element 啦，就喺呢度，其實就係個名啦，個名有少少唔同啫。呢個突然之間有 the neutral element is the identity element， 就係其實所謂 neutral element 就即係 identity element， 即係 the points of infinity。OK， 所以就又係純粹同樣意思，但係個名唔同咁樣。Isogeny over K. If there exists a morphism with coefficient in K mapping the neutral element of E to the neutral element of E prime. 哦，吓，就係咁。吓？如果引用呢一個咁嘅 definition 嘅話，應該something strange 啦，人下面都講嗱。如果以咁樣理解啦，簡單嚟講咧，咩叫 isogeny 咧？就係講緊啦，如果兩個 curve 咁呢兩個 curve 咧就係 in specific 就係講呢個 elliptic curve 啦。兩個 elliptic curve 點樣先叫 isogeny 咧？就係咧，如果譬如話有兩個 curve 啦，一個叫 curve A， 一個 curve B。如果 curve A、curve B， 如果 curve A 同 curve B 之間有一個 map， 你個 map 咧存在一個特點嘅，就係咧可以將 curve A 嘅 points of infinity map 去 curve B 嘅 points of infinity 度嘅話咧，咁呢兩個 curve 就係 isogeny。但就係啦，我覺得唔係好 trivial 咩？即係你好似零 map 去零咁樣，好應該好 make sense 嘅。Something strange is going on here. The definition talks about two curves being isogynous. That sounds like symmetric relationship, huh? But the definition is not symmetric. What the heck? Symmetric. 突然之間我突然講啲咩 symmetric relationship. Symmetric. But the definition is not symmetric. It specifies the existence of a morphism in one direction, but not in the other. But the book goes on to explain that if an isogeny exists in one direction, there necessarily exists a unique isogeny in the opposite direction. The dual isogeny. 唔係 dual， a dual。兩個，唔係 dual， 與其話兩個，係咯兩個，或者一 pair 咁出現啦，好似個意思係。Though it's not obvious why this should be. Okay. 所以佢覺得奇怪嘅位唔係我覺得奇怪嘅位咯，我覺得奇怪嘅位就係兩個 curve 嘅 points of infinity 互相 map to each other 就好似一件幾 make sense 嘅嘢。即係 I mean 所謂 make sense 就真係應該話幾 trivial 嘅嘢。我覺得所有嘅elliptic curve 嘅 points of infinity 都可以 map 到去 each other 咁樣，但可能實際唔係，我唔知。但呢度話咧，佢呢本書咧就講咗咧，如果A 去 B 有個 isogeny map 嘅話咧。咁就會 imply B 去 A 都會有個 isogeny map，which is kind of bijective 咁樣 equivalent 啫嘛。咁要 proof 啦，可能係就係 I mean 要 proof 啦呢一樣嘢。Another puzzling thing is that it doesn't seem to take much for a function to be an isogeny。係咯，呢個就應該係我想問嘅問題啦。Just map the group identity to the group identity。係咯，我就覺得其實就係你。兩個 curve， 你將你求其整一個 map 出嚟，而呢個 map 就係將啲 identity map 去另外一個 identity 度，咁咪得咯。But there are other requirements implicit in the statement that 我唔記咗呢個符號點讀添，呢個符號點讀啊 ？Fine， 好似係 fine。Fine is a morphism in the context of algebraic group. 暫時都唔係太明。總之佢話有啲原因令到呢樣嘢唔係 trivial 啦。唔一定係即係兩個 elliptic curve 唔一定可以存在一個 map 係可以即係 map 到。一個嘅 group identity 去另外一個 group 嘅 identity 度 ，which is 個原因係唔知咧。Cohen and Frey do not require Fine to be a homomorphism, as some authors do, but they point out that in fact Fine will turn out to be a group homomorphism. They say for more background on isogenies, we refer to section 4.3.4 Okay, let's go there. Okay. In that section, the authors say that a morphism between a billion varieties 唔知咩叫 a billion varieties。A billion 嘅意思我大概知係 A 乘 B 等於 B 乘 A 咁樣嘅意思啦，即係 commutative 啦，類似以我所知，但我唔知呢度嘅 a billion 係咪嗰個意思，應該係。It's an isogeny if and only if it is surjective and has finite kernel. What the heck? That seems like a much stronger requirement than the definition above. However, in this context, simply requiring a morphism to map the group identity to the group identity implies that the morphism will be surjective and have finite kernel and vice versa. 即係講緊一個 morphism， 一個可以將 A 嘅 group identity map 去 B 嘅 group identity 嘅一個 map 咧，係 equivalent to 一個 surjective and have finite kernel 嘅 map 嘅，嚇。isogeny 係一個 group homo， 佢係一個 homomorphism 嚟嘅，但係佢唔係一個 isomorphism。Not in the modern usage of the term， 即係依家 isomorphism 同埋 isogeny 係唔 equivalent 啦，但係 historically 以前嚟講咧 isomorphism was used for what we now call an isogeny。以前嘅話 isomorphism 其實係就 exactly 就係 isogeny。We said above that the existence of an isogeny in one direction implied the existence of a dual isogeny in the opposite direction。係咯，啱啱明話如果 A 去 B 係 isogeny， 就一定會存在另一個 B 去 A 嘅 isogeny。咁唔似一個 isomorphism 咩？These functions are not inverse of each other. Their composition is not the identity, however. 即係簡單嚟講 ，A 去 B 嘅 isogeny 同 B 去 A 嘅 isogeny 未必係完全有 inverse 嘅關係嘅。正常一個 bijective map 嘅話，即係 A 去 B 去翻 A 咁樣，佢係 kind of 係一個 inverse 嚟㗎嘛。係咯 ，for isomorphism 係咪都係啊？好似應該係一個 bijective map 應該就係、所謂睇到 bijective 嘅話就係 A 去 B 可以去翻 A， 同時 A 去 B 同 B 去 A 嘅 function 應該係一個有 inverse 嘅關係，咁就係 bijective 啦，係嘛？但呢度 isogeny A 去 B isogeny 同 B 去 A isogeny 係冇一個 inverse 嘅關係，可能係。However, their composition does not have a simple form. It is multiplication by an integer n, called the degree of the isogeny. Multiplication here means repeated group addition, i.e. the composition takes an element x to the sum of n copies of x using the group law of the elliptic curve. Don't understand. 睇下先，呢個 example。呢一個 map of an isogeny of degree 2 between the elliptic curve 呢個 and 呢個 over the field of 2003 elements. The curves are not isomorphic because the group structure of the former is a cyclic group and the group structure of the later is not. OK， 呢兩個 curve 嘅結構唔同，咁所以佢哋唔係 isomorphic， 但係佢哋係 isogeny。係咪就係係咪就係因為佢哋兩個個 kernel 個 element 都係有同樣數目嘅 kernel？ I mean 就係個 kernel 嘅大細，呢兩個 map 個 kernel 嘅大細都係 I mean 黐線，呢個 map 唔知講緊啲咩，等陣先。應該話呢兩個 curve 嘅 identity element 嘅數量一樣，關唔關事？唔 sure 啊，是但。Incidentally, there is a theorem that says two elliptic curves over a finite field are isogeny if and only if they have the same number of points. OK， 如果呢兩個 elliptic curve 總之其實所以呢度兩個 curve 係 isogeny， 其實係 equivalent to 佢哋兩個 curve 有同樣數目嘅點所以佢啱啱阿 Bourchtein 就講，我係 save 低呢一個 ，save 低 math 度先。用 map 呢個書籤列，I see。難怪 Bourchtein 啱啱就講呢個，所以 isogeny 就係 related to 個 number of points 因為佢 isogeny 係 equivalent to 兩個 curve 有 same number of points。So a brute force approach to show that the curve above are isogynous would be to show that they both have the same number of points. See， 咁我明白了。所以呢度呢，佢其中一個分 class 嘅方法就係根據嗰個 curve 嘅 number of points 嚟分。就係如果嗰兩個 curve 有 same number of points， 佢就分做同一個 group， 同一個 class 應該話 ，which is 兩個 curve 有同樣 number of point 就係有一個 isogeny 嘅關係啦。わかりました。但 same number of points 唔代表一定係 isomorphic。都可以理解嘅。即係又 relate 到少少落去呢個 topology 嗰度。 點講呢？唉，冇嘢啦。佢啱啱都講咗少少，總之就係、即係 suppose 其實真係兩個如果兩個 curve 佢哋有 same number of points 係兩個 curve A curve B 佢哋有 same number of points 咧，就正常就一定會存在一個 bijection 嘅。咁既然兩個 same number of points 啊嘛，咁你將 finite 先重要，咁你咪將逐個 point 好似連線咁樣連起佢咪得咯咁樣。bijection 就一定有嘅，但係咧 isomorphic 佢唔單止係 bijection，即係唔單止係 bijective 啊嘛，仲要係 homomorphic 啊嘛，即係就要達成某啲條件嘅，即係 kind of 個條件係會令到佢哋嘅結構一樣啦，係點數一樣之餘，仲要個結構要一樣咁樣，所以 OK 大概明白。subsets of elliptic curve。跟住係 equivalent class，咁所以就係、咁我就有個 subset，總之有個 group 啦，依家就係呢個 group 咧就係包含晒所有嘅 isomorphism equivalent class of elliptic curve。咁我哋啱啱就已經做晒分 class 啦，將啲 elliptic curve 咁樣分完 class 之後，我就每個 class 就係一個 element， 咁就 form 咗個 set。咁我喺呢個 set 入面去抽個 subset 出嚟。weighted probability 呢度就唔明啦，突然彈咗 automorphism 出嚟。associated weighted probability 乜鬼嘢嚟？但咩叫 weighted probability？ associated weighted點樣讀得好啲呢個字 ？probability morning yeah hi 你返嚟啦，往哪裏去了？你啱啱離開嗰陣時，我已經明白咗咩叫 isogeny。而家到下面呢個乜鬼嘢associated weight點樣讀到啲 associated weight associate weight probability，OK， 係就問下知呢嚿係乜嘢？啲 stack 嘅嘢，點解用啲 stack 嘅嘢去污染我哋嘅數學？點解要咁樣做？Definition。哇！乜鬼嘢嚟 ？Weight mean 反而有片，但係就冇 definition。Situation when the probability of similar events occurring is not equal。明白。Weight probability 就係咁簡單地，因為每件事點講呢？正常嚟講，你有譬如話有 n 種可能性啦，就係講話全部可能性有 n 種。你話 n 種入面 n 種即係嗰咁成 n 個可能性入面發生某 k 種事情嘅機率係幾多咁樣？咁就係好直接地就係 k 除以 n 啦。咁但係嗰 k 種事情，佢每件事情發生嘅機率都有唔同啊嘛。咁所以要可能點講啊 ？mean have 咩啊 ？bias 呢度 bias 係咪咁樣意思？我唔知你個 bias 係咪類似咁嘅意思？所以簡單嚟講，即係其實即係有冇啲咩例子？咩袋入面有蘋果、香蕉、橙咁樣，咁話咩抽到香蕉嘅可能性係幾多啊？咁樣，咁正常如果呢個袋有蘋果、香蕉、橙咁樣，個袋入面得一個蘋果、一個香蕉、一個橙嘅話，咁樣抽到香蕉機率就梗係1/3啦，係咪先？咁但係原來個袋咧有一個蘋果、2隻香蕉、1隻橙咁樣嘅，咁即係叫做抽到香蕉嘅比重啦，即係 weight 啦，係重啲嘅，個比重係大啲嘅，咁所以就要乘翻大佢咁樣啦 ，kind of 係。如果根據呢度咁講，跟住呢一度又係點樣呢？同埋點解要考慮佢 automorphism 呢？佢應該解釋緊點解要突然之間考慮 automorphism。佢話如果考慮到佢未講完嘅，但我好似 get 到少少就係咁。首先點解要 weight 咧？即係佢依家佢將啲 elliptic curve 分咗 classes， 咁但係其實每個 class 個大細唔同啊嘛。每個 class 大細唔同嘅話，我點可以當每個 class 發生嘅機率都係一樣咧？咁樣，咁所以就要 weight 翻佢哋嘅。 咁但係點解 weight 佢哋嘅方法係用一個 automorphism，就係要計佢哋 automorphism 咧？咁就繼續聽落去啦。但佢都冇解釋到點解用 automorphism。Anyway。先number of automorphism。嗱，估咋嚇？我唔知個 number of automorphism 係咪個 number of automorphism 係咪就 kind of 等於佢個 class size 咁樣？我唔 sure 係咪？但係好似 probably 係啦，呢個上次講咗啦，就係我哋即係佢哋考慮嘅，就係啱啱抽個 subset 啊嘛，subset epsilon，咁佢哋抽嘅 subset 就係嗰啲 elliptic curve 嘅 trace 都係 congruent to 細 m mod 大 m 嘅。咁最後個結論就係發現係啦，得出嚟個結論都係個 probability 都係等於呢個 integral， 就係 kind of 佢哋 approve 咗其中一 part 嘅嘢啦。本身呢個咩沙糖塔梯沙湯梯嘅嘅 conjecture 就係講緊所有嘅，如果考慮所有嘅 elliptic curve 嘅時候，咁佢哋嘅 probability 就會係等於呢個 integral。咁佢而家呢度就負責咗就係其中一 part 就係我唔考慮所有 elliptic curve， 唔考慮所有 elliptic curve， 我考慮嗰啲 trace 係 congruent to m mod m 嘅 elliptic curve 嘅話，咁 probability 其實都係呢個 probability。呢度上次睇到呢度，好似有啲眼瞓，諗到即係佢去 observe 個 probability， 睇先。 佢 observe 嘅時候咧，佢就將點樣形容咧？係呢度佢哋想睇嘅係呢一個 x 啊嘛 ，xe 啊嘛呢一個佢其實實質想 observe 嘅係呢個 xe 啊，即係個偏差係幾多啦？個偏差係幾多 ？Which is 佢哋一開始最主要嘅題目就係講緊咩？一個 elliptic curve over 一個 finite field 有幾多個 solution？ 係啦，一個 elliptic curve over a finite field 有幾多 solution？ 好似冇理解錯啊，係咁樣啊嘛，係咯，係啦。觀察呢樣嘢嘅時候，佢哋有個即係有人叫做咦？佢講過啲咩？睇下先。The number of solution 嘅 expected value 就係呢個 P 嘅 R 次方加1啦。咁就知個 expected value， 咁樣就總會有啲偏差嘅。咁個偏差就係、你當係大概係就係 xe 呢個數啦咁樣。where xe 係等於某個數啦咁樣，但係總之呢個就係所謂嗰個偏差啦。我哋就係想觀察呢個偏差。咁我就唔知點解佢哋用 probability 嘅方法去觀察呢個偏差咁樣啦。但係去到後面啦，咁佢哋咧就呢度就開始講一樣嘢啦。咁去觀察呢個偏差咧，唔同 elliptic curve E 嘅偏差咁樣都唔同啊嘛。即係可能 E1、E2、E3咁樣，呢個 xe1 同 xe2係唔同咁樣。咁點樣觀察佢咧？佢嘅做法就係將佢哋放成一排，將第一個偏差加第二個偏差加第三個偏差加第四個偏差 blah blah 咁樣放埋一齊加咁樣，但係同時咧佢會將每個偏差都會成 k 次方咁樣，呢個就 kappa 次方，佢 kind of 係令到個放大個偏差去觀察佢咁樣咧，佢好似講，但我唔知究竟點樣可以，即係佢將佢成咗幾次方咁樣放大咗之後，又點樣有助佢觀察個偏差咧？我又唔係太清楚。原來我一直都冇開到佢個聲。
Any kind of reasonable distribution is actually determined by the moments. So here we have the weighted moments. So we take the x sub e to the kappa power, where kappa is some.
等陣先，唔好意思。冇嘢啦，聽下先。
Now, so how do we go about this? The basic idea is that any kind of reasonable distribution is actually determined by the moments. So here we have the weighted moments. So we take the.
等陣先。點解將輸出音效搞得咁低？唔係太明。
We take the x sub e to the kappa power, where kappa is some integer bigger than or equal to 0. So here we have that any kind of reasonable distribution independent of each other. Now, so how do we go about this? The basic idea is that any kind of reasonable distribution is actually determined by the moments. So here we have the weighted moments. So we take the x sub e to the kappa power, where kappa is some integer bigger than or equal to 0. And you can think of it like this. The moments, so if the x sub e is very small and we take it to a large power, it gets smaller and smaller. But if it's very big, then it doesn't get small at the same rate. So it turns out that by some probabilistic methods, you can prove that if you can figure out all of the moments, that completely determines the original distribution. So it tells you the probability overall.
實際點解可以咁操作都唔係太明，但係總之佢就話佢靠呢種方法，就係佢因為成次方咁樣嘅話，咁細嘅嗰啲就會即係點講呢？因為佢哋所有呢啲 x 都係一個細過1嘅一個數嚟啦，同埋細過1大過負1，喺呢個 range 入面嘅數，即係0點幾咁樣啦。咁0點幾呢啲數成次方咁樣嘅話呢，咁如果佢本身佢個數越細，係話佢本身個 x 越細呢，佢成完次方之後呢，佢會越變越細啦咁樣。但係如果嗰個 x 係冇咁細嘅話呢，咁佢變細嘅速度會相對地冇咁慢咁樣 ，kind of 係咁樣。總之就靠過呢種咁樣就去 amplify 個每個 x 之間個差距嘅方法，就令到我哋可以觀察到佢個 probability。唔知用咩方法，但係總之佢就咁樣講。
And so we study these, and we show that as the prime goes to infinity, this converges to the same as the moment of the integral. And what is important is that, see here we go from a to b. For the moments, we just have to go from -1 to 1. But then we have to take the powers of this. We have to take powers of x here, because that's what sort of is varying here, right? We're taking x to some power, and so we have to take x to some power inside the integral. And so we have to compute and compare the moments in the integral and the moments in the discrete distribution that we're looking at. And we have to show that one converges to the other. As the prime goes to infinity, it should converge to the other distribution. That's equivalent to what we're claiming. This is the same method used by Birch, so this is nothing new. This is an old method, and it was used before Birch to prove that certain distributions are the same. So instead of taking this, we take the trace itself to the kappath power. But remember that this is just the trace divided by 2p to the square root of p to the r.
呢個 x 其實同個 trace 係差唔多嘅嘢，就只係其實我哋本身就係觀察緊呢個 trace 嘛，個 trace 係嗰個偏差啊嘛。咁只係如果我將個 trace 去除翻某個數，就係等於呢個 x 咯。即係所以其實 x 同個 trace 係 kind of 係 proportional， 可唔可以用 proportional 嚟形容？但係總之係類似嘅嘢嚟㗎啦，所以 nothing new 都係個偏差嚟。咁就所以define 呢一嚿嘢 SKMM kappa OK， 即係 S kappa MM kappa 就係個 moment 個 index， 就係成幾個次方啦每個 term。MM 就係我考慮個堆 elliptic curve 佢個 trace 係個 trace 係 congruent to 細 n mod 大 M 嘅。OK。
So there's just a p power and a 2 power that vary between these two definitions. So
p power and
computing
power.
one and the other is equivalent. Okay, so that's the relationship between the two. And what we prove is, in other words, to be able to understand these moments, we prove that if we take this ratio of the kappath moment to the 0th moment times some 2 power and some p power, which is, sorry, this should be, I think I want p to the r here and p to the r here. I think so, yeah. So I think I should have p to the r here and p to the r kappa over 2 there. And then what we get is, we get that this is the Catalan number divided by 2 to the 2k if kappa is even, and it's 0 plus some error term that goes to 0 as p goes to infinity if kappa is odd. And this sort of makes sense.
上面就係、下面呢個呢，你見呢度就冇咗個 kappa 喺度啦，就上面係 kappa mm， 呢個就齋得 mm， 冇咗個 kappa 嘅話，即係佢個 moment 係0次方、1次方定0次方
is over 2 there. I think so, yeah. So it should be times some 2, and these moments is. And what we prove is, in other words, to be able to understand these moments, we prove that if we take this ratio of the kappath moment to the 0th moment,
0th moment 0次方嘅話，佢啲分子變晒1嘅嘞喎。係咯，佢啲分子變晒1嘅嘞喎。同埋0嘅0次方係第幾多？如果咁啱個偏差係0嘅話，咁咪大鑊。0嘅0次方係0。Anyway， 我可以 mark 低佢 as questions。唉，冇啦，唉，知不去咗邊？唉，是但，mark 低先。如果個 trace 係等於0，啱啱最後第一個問題係咩？點解要考慮 number of automorphism？ OK。
times some 2 power and some p power, which over, and it's 0 plus some error term that goes to 0.
呢個應該讀 zero 咩？唔係呢個唔係 big O notation 嚟嘅咩
？0 as p goes to infinity if kappa is odd. And this sort of makes sense because we sort of know from Sato-Tate conjecture, we sort of know that these normalized traces are sort of equally often positive and negative. So as we take an odd, if we take an odd moment, then you sort of expect things to cancel. And in Birch's case, they just cancel directly. In Birch's case, there's actually a bijection between those that have a positive value and a negative value, and they cancel. But of course, the congruence condition may not be satisfied when you go from plus to minus. So then they don't directly cancel in our case. So we have to actually do something here to prove that this really does cancel. But it does what you expect it to do. You would expect cancellation if you take a bunch of pluses and minuses. You expect some cancellation at least. And you see as the even moments won't have any cancellation because you're taking a negative number to an even power. So the alternation in sign disappears. And we compare this with what happens for the Sato-Tate distribution. So we're taking the integral of x to the kappa of mu of x dx. So as I said, we amplify it by this x to the kappa. That's the moment for the integral. So you can think of an integral as a sum in some sense, right? You can write it as a sum, as a limit of a sum. And you get this integral can be computed as ck divided by 2 to the 2k if kappa is even and equal to 2k and 0 otherwise. So these exactly match in the limit.
但點解佢個 moment 係乘呢個 x 嘅 kappa 次方？唔係直接呢個 mu 乘以 kappa 次方。
And that's how you prove the previous claim. So far I haven't mentioned class numbers at all. So you might wonder where those come in. So far we just talked about elliptic curves. Well, Schuf, again, this was mentioned in Kanona's talk, showed, so using Deuring's results and making them explicit, he showed that for most of the T, the number of classes in the isogeny class, so the number of classes that have the same trace, T, for some fixed T, is a class number of an imaginary quadratic field. So this is the Hurwitz class number. And what you do is you take our moments and you rewrite it by just counting these things that have that T. You get this, which is just the same thing, plus some error term, essentially. So there's some that don't exactly match, and you have to do something in those cases. So you kind of get this formula.
Let's see. 所以呢個佢對偏差嘅 moment 呢，就其實就 exactly 就同呢個 Hurwitz 係咪 Hurwitz 啊？唔記得咗佢 Hurwitz class number 有關嘅再加啲 error term。
And it moves the problem. So using this result of Schuf, it moves the problem to studying these moments of class numbers. And so this is where we look now at class numbers to be able to do something about elliptic curves. This, as I said, this is the Hurwitz class number, which sort of counts the imaginary quadratic fields or the imaginary quadratic orders of a certain type. From the point of view of binary quadratic forms, I'll describe it in the next slide.
Oh, neglectable.
And you can show that this error term is actually an error term. So I won't really discuss that. This is fairly explicit. You can bound it using some straightforward techniques. And now we have to study these moments. So the Hurwitz class numbers from the point of view of binary quadratic forms just counts the pairs A, B, C of discriminant D
佢打嘅嘢好似我
for D less than
好似我之前做 present PowerPoint 打嘅其中一版
0, something but I times a constant.
後面就應該就已經係我做過嘅某啲嘢，所以我應該可以好快睇得明。睇下先 ，weight by 1/2 if 呢一個 quadratic form 係咩啊
A and B and C can have a non-trivial GCD. And I weight them by a half if they're equivalent to x squared plus y squared times a constant. And I weight them by
times a constant. 如果 A 同 A 等於 C 而 B 等於0，即係1、0、1咁樣，佢就 weight by half。如果係1、1、1咁就 weight by 呢個 third.
By a third if they're equivalent to x squared plus xy. I give a slightly different way.
Okay.
Things is we're going to view these class number moments as coefficients of automorphic forms or modular forms in some setting. So we want to build generating functions that have these as their coefficients, and that's how we're going to proceed forward. We start out with a theta function, which is just exactly the moment showing up. So this t is satisfying the same congruence conditions. We take t to the kappa, right? N equals d.
呢個我係咪唔使睇嘅啦？其實定係我都照睇啦，睇下佢有冇啲咩新補充。
We take the kappath moment, q to the t squared. And then we take the generating function for the class numbers, and we take their product.
突然見到啲自己見過嘅其實我見過，真係叫好有親切感啊！真係唔識形容我識㗎，竟然係咁樣 但我唔想詳細解釋，算啦。照講啦。總之佢依家本身佢即係觀察呢一個偏差啦嘅 moment， 個偏差嘅 moment， 咁偏差嘅 moment 啱嘅。咁但係就發現就其實就係、對偏差嘅 moment 咧就 related to Harris class number 嘅。咁就都成啲 moment 啦，喺度係成 T 嘅 moment 啦，呢度係。咁所以我哋就可以轉去觀察呢個 Harris class number。咁 Harris class number 係乜嘢咧？就唔係太過重要嘅喺呢度。Classes of binary quadratic form 唔係太重要。等先。咁咧就 define 咗啲新嘅 function 出嚟啫。呢個咁嘅 h 就係嗰堆 Harris class number 啦。呢個 curve h 就指其實就只係呢啲 Harris class number 再乘 q 嘅 d 次方，因為 q 係另外一個 function 嚟㗎啦。q 係另外某啲 function 啦 ，depend on set 嘅。但唔算太重要，總之就係佢將呢堆 Harris class number 佢再 form 咗另外一個 curve h 呢個 function 出嚟，然之後我再乘埋呢個 theta function， 咁就 form 咗另外一楷 function 出嚟。
Together, and I write n equals d squared plus t squared, then rearrange.
係咯 ，by changing 呢個 subject， 唔太重要，即係呢個 q 嘅 d 次方啦，呢個 q 嘅 t square 次方啦。咁純粹將佢簡化，就係佢兩個q t square 加 d 咁樣就變咗做 n 咁樣簡化咗佢，然後搞咗啲楷嘢出嚟。
Ranging, I get this formula, and you see that the coefficient kappa for the problem's individual detail. I'm going to cheat a little bit. I'm going to take a sort of simpler path, although the method that we use is actually the same as the one that Ken did. So I'm going to describe this in a slightly simpler way, just to make it perhaps easier to follow what's going on. So we want to study the modular properties of this product. Now this theta is almost a modular form. If I put kappa is 0, it is a modular form of weight 1/2 on some group. And if I put kappa equals 1, it's also a modular form of weight 3/2 on some group. So as Ken described it, he started with these, and then he used something called Rankin-Cohen brackets to go up in weight. And so he was really dealing with modular forms. But you can also simply take these and take derivatives of them. If kappa is even, I take derivatives of the theta 0. And if kappa is odd, I take derivatives of the theta 1. And if I take k derivatives, I get the 2kth moment here. And here I get the 2k plus first moment. I mean the theta function corresponding to our 2k plus first moment in the previous slide.
但是呢度開始唔明啦，突然之間 derivative 吓，即係點啊？即係如果我 differentiate 呢個 theta function， d 唔知幾多次，我就會出咗呢嚿。kappa kappa moment 嘅 theta 出嚟，重唔重要？唔重要。
But
derivatives of modular form are quasi-modular form.
of modular forms are what we call quasi-modular forms. And quasi-modular forms miss being modular forms by only a little bit in some sense.
哇！呢一個 definition 我以前未聽過。識 quasi-modular form 我都唔係太記得 quasi-modular form 係大概係真係點樣，但係佢呢度直情講咗 quasi-modular form 就只係 derivative of a modular form。
We have some way to sort of fix them to make them into some kind of modular object. So what is a modular property? You are familiar with them.
你講多次。
So what is a modular form? I know.
哇！唔緊要，就係教學技巧上咧，我哋唔會點樣講咧？我都有提及過，就係去教學生一樣新嘅嘢咧，我哋會叫做有個可唔可以叫技巧咧？都叫技巧嘅一個，其實我覺得 instead of 技巧，不如話其實有個 principle 係需要去留意、去遵守嘅，就係你教學生新嘢，你要從佢本身識嘅嘢度開始講，而唔係直接就答個名出嚟。譬如呢一度就係佢突然之間前面就呢度咁早就彈咗個 modular form 出嚟，然之後大家一頭霧水，哦咁其實咩係 modular form 咁樣，佢係後面再講翻出嚟咁樣，咁呢一種係唔好嘅教學方式嚟嘅 kind of 係，咁但係唔緊要，就係呢樣讀教育嘅話會有講過啦，當然就未必，所以冇話點樣嘅，純粹咁樣講一講啫，係啊。
Some of you are familiar with them. Some of them may not be. That cz plus d to the minus k times f of gamma z is f. For some subgroup of SL2z, it's holomorphic on the upper half plane, and it's bounded towards the cusp. So if you go radially down towards h over k,
但係都係嘅，其實即係 kind of 其實佢 modular form 應該，我嗰陣時做 present 嗰陣時，其實都冇點樣着手去講咩係 modular form， 因為其實都唔係個重點咯。個 modular form 嘅 definition 係乜嘢？
Be bounded in some way, or at least the growth doesn't go too far, too fast. Just polynomial growth.
所以唔緊要嘅，總之就。
We allow half integral weight. So for this, we have a kind of multiplier system. Without the multiplier system, these don't exist. They can't simultaneously, because of the square root not being, because of the branch cut of the square root, it's impossible to have it just be cz plus d to the minus k when k is a half integer. So we have this extra factor that sort of fixes that. And we have, this always has absolute value 1 when we deal with these. Again, we assume holomorphicity and bounded growth towards the cusps. So what are these quasi-modular forms? Well, I assume the same kind of property, but now I change something. I change it so it's no longer necessarily holomorphic. I take a polynomial in the inverse of the imaginary part. So z is x plus iy here. I take a polynomial in the imaginary part with coefficients that are holomorphic. And this thing is what's going to replace holomorphicity. So it's almost holomorphic, which is why this name is given. And some people call it nearly holomorphic, depending on the literature. And the constant term, the f0, is what we call a quasi-modular form. So these derivatives of modular forms are proven to be quasi-modular forms. So these derivatives, every time you take a derivative, the L goes up by 1. is what happens. So these derivatives of the theta function are of this type. They are the holomorphic part. There's no power of y here, so they're sort of the holomorphic part of an almost holomorphic modular form. So they're not too far from being modular forms in some sense. Now Zagier looked at the class number generating function, these Hurwitz class numbers, looked at the generating function, and found that it's almost a modular form as well. And in what way is it almost a modular form? Well, we have to add this non-holomorphic piece, which many years later was proven to be part of a sort of family of objects called harmonic Moss forms. So this H hat is what's called a harmonic Moss form. We don't care too much about the properties of harmonic Moss forms for this talk, but the main important fact that we want is that this transforms like a weight 3/2 modular form. So we have a weight 3/2 modular form that's non-holomorphic times times an almost holomorphic modular form. And if we take the product of those, we'll get some modular object, but we only want some piece of that, right? We want the non-holomorphic, we want the holomorphic piece. We just want this product, which we had to add something. We have to add these other terms for the almost holomorphic modular form.
Easy.
And we have to add these terms
呢個 easy 因為你
for the class number generating function.
唔係喎，不如話你講呢句 easy 包括咗我
So
教
we
咗你
complete
幾
both
多
of？ them, and then we take the product.
係咪應該我講 easy？
And this will be
係
a
唔緊
kappa
要啦。
plus tooth non-holomorphic modular form because when we take the derivatives, the weight goes up by 2 every
唔係
time.
其實個
So
easy
the
係
weight
有
here will
好
be
多嘢其實
exactly
可以唔需要咁
kappa
知道
plus a
嘅，
half,
可以忽略
and this
嘅。
one has weight 3/2. So when we add them together, we get kappa plus 2. So this is a modular object, but it's not holomorphic. And what we'd like to do is we'd like to understand the holomorphic part of this that comes from not having the hats.
我知其實簡單嚟講係佢中間佢係將好多嘢係串連埋一齊，即係佢其實係佢想觀察一嚿嘢。佢個比喻係佢想，譬如話你想望個太陽咁樣，你冇辦法去直接用對眼去望個太陽。咁當然我哋嘅原因就係因為直接望個太陽你可能會慢啦。咁但係呢度就係好難去直接望個太陽，所以要用其他嘅方式去間接咁樣去望個太陽。係話以前學過嘅就係你攞兜墨水黑色嘅水啦咁樣，然之後放喺地下度，然之後係望嗰兜黑色嘅水咁樣 ，kind of 咁樣。咁呢度其實就係咯，佢本身係觀察緊 elliptic curve 嘅 solution 嘅數目嘅偏差咁樣咁但係佢又發現呢樣嘢係同 Hurwitz class number 有關嘅，咁佢轉咗去觀察 Hurwitz class number。即係原來 Hurwitz class number 咧，其實就係佢同 modular form 有關嘅。咁但係佢又唔 exactly 係一個 modular form 咁樣，係嘛？咁所以要觀察一啲差 almost modular form 嘅嘢。點啊？食啊！陣間。OK，佢係觀察啲 almost modular form 嘅嘢，blah blah 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 咁樣。
So what do we know about non-holomorphic modular forms? What can we learn from these objects? Well, we have, on holomorphic modular forms, we have an inner product that Peterson defined. So if we have f and g, we have the inner product between them. Well, you might ask why this is well defined. So f times g bar, the imaginary part to the kth power, dx dy over y squared if it says
我對佢係咪真係嗰一啲分冇乜興趣其實。 睇下先。呢啲係冇印象，我喺之前做 project 嘅時候有望過。
In the z part and sum modularity, product has weight k modularity weight minus 1. The change of range in compute using the fact the determinant is 1, you can actually show that this is a modular object of weight minus 1 minus 1. And so when I multiply them together, this becomes invariant because this is weight k, k0, 0k, so kk, minus k, I get 0, 0, that's invariant. And the measure is also invariant, you can prove that, so everything is well defined. Now there's also a question of convergence. We won't worry too much about that. If these are cusp forms, it's fine. But we also want to take not just cusp forms, we want to even plug in non-holomorphic objects. But here's something that's very interesting. It's positive definite on the space of cusp forms. Because if I take this definition, if I take f and g equal to each other, so I take g equals f, then this becomes the absolute value of f squared, and everything is non-negative here. So this is clearly going to be non-negative. The only way we can get a negative value is when things diverge. And indeed, if you try to take an Eisenstein series with itself, the naive integral is divergent. There's an analytic continuation, but then it's not positive definite anymore. So what can we say about a positive definite inner product? Well,
我覺得我個 attention span 已經開始已經下降緊。我嘅即係 kind of 我感覺佢分咗叫做其實呢個 talk 分咗兩 part 啦，前面就係講 elliptic curve 嘅嘢，咁後面發現 elliptic curve 嘅嘢其實就係 related to 呢個 Hurst class number， 咁後面就講 Hurst class number 嘅嘢。Where 我發現我有做過某啲同 Hurst class number 嘅嘢嘅時候，我已經開始有啲想快跳，因為我覺得叫做睇過咁樣，但又發現原來有一堆嘢我係未睇過咁樣。但我嘅 attention span 已經 span 咗喺前面嗰一 part 度，同埋佢喺出面食飯，所以幾點啊？而家12點半，咁不如今日就咁樣啦，係啦，今日就咁樣啦，不如係啦，我就係啦，我遲啲睇下幾時再睇埋後面 Hurst class number 嘅嘢啦，唉。我有啲猶豫，我睇後面嗰堆嘢，我究竟學唔學到嘢？應該 OK 嘅。即我相信佢係咯，佢編排嘅時候都係叫做係咯，盡量令到所有人都聽得明咁樣啦，叫做，所以我覺得應該叫做起碼就係如果我係符合佢 expectation 嘅話，我應該都 kind of 後面即係未必需要所有完全吸收得到，但係都應該會睇得明，會有得着咁樣。所以我覺得我可以再留心睇下佢後面嗰啲，咁我就等下次啦。呢個就係啦，暫時就咁多先啦。今日就冇錯，各位依家都夜夜地啦，早唞，我出去食嘢先啦，哈哈。好，就咁先，我哋聽日聽日見啦，聽日應該 OK 嘅。但係聽日會出去打，唔覺得聽日。唔係嘅，私人聚會嘅話應該冇問題。好似係打邊爐。anyway， 好就咁，我哋明天見。返到屋企之後。 開唔開到台咧？或者有冇心情開台咧？唉，唔知啊。如果你哋要好踴躍咁話開啦，加油啊，開啦，咁我咪就一定開噶啦，係咪先？唔知有冇咁樣同我講 ？But anyway， 好，遲啲見啦，總之就係，拜拜。噔噔噔噔噔噔噔噔。